Hello students. My name is Mr. Hlumelo Michael Mbana. Today I'll be doing calculus with you guys. I'll be deriving the first principles equation. I'm hoping that you are familiar with that equation. The equation is given by f prime of x is equals to the limit as h approaches 0, which is f of x plus h minus f of x all over h. So the first thing that I'll do, guys, I'll first derive this equation for you guys to see where it's coming from, because if you don't know where it's coming from, maybe you'll have difficulties in terms of having to understand how the equation works. And yeah, I believe that in most cases we need to derive stuff to so that you could understand better, also that you could have a better understanding of what you are doing. You don't just do cramming or plug and chatting, you understand? So say for instance you have your y-axis and you have your x-axis. Let me extend this a bit. These are your x-axis and these are your y-axis. So now say for instance you are given a function which is an exponential function, an increasing function, a function like this. You are given then for this function, and then this function is equals to f, right? Or maybe for argument's sake the function is f of x is equals to a raised to x, where a is greater than 1. Oh, I don't think you can see that, where a is greater than 1. So the all increasing functions or increasing exponential functions that are shaped like this have to go according to this formula. So now the first thing you want to do, you want to pick a point on this curve, a point here, and we can call this point A, right? And then the second thing you want to do, let me extend my x-axis as well because I think I'm running out of space. Okay, the second thing you want to do is to pick another point, a second point. We name this point B. So now, if say for instance the A point has an x value, for argument's sake, let's let it to be x, right? So the corresponding y value, you guys know that y is equals to f of the function of x, right? So which therefore means that the corresponding y value here should be f of x, right? If say now with respect to x, coming from the A point to the B point with respect to x, let's assume, or let's say that the distance from this point to that point, the distance that we travel will be h. Let's say the distance from here to there, it will be h. So that will mean that the coordinates of x at point B will be x plus h. So this is the what? This is your x value at point B. So the x value at point A is x, and then the corresponding y value will be f of x. And then at point B, we said we're traveling from this point to that point, so we're traveling h units. So which therefore means the distance from point A to point B with respect to x, it should be x plus h. And then now the corresponding y value to x plus h, it should be f of x plus h. I don't know if you guys can understand that, but we said for this point, if this is x, then this function should be, the y value should be a function of x, so it should be f of x. And then now if at point B we've got if at point B we've got x plus h as our x coordinate, then it means the corresponding y value should be f of whatever is in x, so which is f of x plus h. So the x value of B point, it will be x plus h, and then the y value would be f of x plus h. And then we've got 2 points here, point A, point A has got point X and the corresponding Y value, f of X. And then we've got point B given by X plus H. And then the corresponding Y value will be f of X plus H. So now this is our point 1. This is our second point. This, I don't know if you can see this, but let me try to move my cameras. This is our second point. So now the idea is for us to choose, okay, to let this to be x1 and to let the y value to be y1, and then this will be x2, then this will be y2. So this therefore means that what we need to do now, we need to find the gradient between these 2 points. But before we do that, we need to understand one thing, guys, that if, say, for instance, we are given a tangent line here, a tangent line, a straight line, a tangent, it's a straight line. So now we're given this straight line, right? So if you get to think about it, the equation f, or the function f, let's say for argument's sake, this is g, the straight line is g. So the gradient of the straight line at point A and the gradient of the curve f at point A will be the same, because that is their point of intersection. So at that point their gradients will be what? It will be the same. So what we need to do now, we need to find a way of manipulating the gradients of these two functions to be the same. So what we do is to firstly to find the gradients between 2 points. So we know that the gradient between A and B is given by the formula change in y over change in x, which means it's y2 minus y1, all divided by x2 minus x1, right? So we did agree that this is our y2, this is our y1, and this is our x2, that is our x1. So coming into substitution, our y2 will be f of x plus h minus f of x, which is minus y1, all divided by x2 being x plus h minus x. So now the gradient between point A and B is given by the formula f of x plus h minus f of x all over. Okay, if you notice here, this x will cancel this x, and then we'll be left with what? With h. So I hope you guys can see this. The gradient at point B can't be the same as the gradient at this point, because these functions are not even parallel. There's nothing that combines this point and this. There's no point of intersection between these two curves or functions, if I may call it. So we need to find the gradient where at this point. So now if you get to think about it, we took the gradient, this is change in x, and then this is change in y. So change in y over change in x will give you the gradient of point A and B. But we're not interested in the gradient of point B. What we're interested in the gradient of point what? Of point A, because point A gives a gradient that is the same for both functions. So now we said from this x to this point, this with respect to x, we will travel h units, right? So now if you get to think about it, if we can choose a point here, your h will be approaching this point, or if you can decide to decrease our h distance, this your h value will be approaching what? Will be approaching this point. So which therefore means that now we need to agree that our gradient of A, b should be limited by putting limits as h approaches 0. So by putting these limits now, we mean that we need to say f of x plus h minus f of x all over h. So now what we are doing, we make h to approach 0 because we want to limit, we want this h to be closer and closer and closer to point A, because we don't want our h value to include even that b value, because the difference will be too large. You understand? So that is how we find the equation from first principles. So now we will say the gradient is also equals to your derivative, which is equals to your limit as h approaches 0 into f of x plus h minus f of x all over h. So this is the equation. So now what this means, it means a derivative is the same as the gradient where at a particular point. So now I'll show you an example of deriving using first principles. I'll show you an example just now. Yeah, welcome back. So say for instance you are given a function f of x is equals to x squared, and then you are asked, or rather required, to derive this equation or function using first principles. So we know that deriving this thing, using first principles, we know that the formula for first principles is given by f of x is equal to the limit as h approaches 0 into f of x plus h minus f of x all over h. So now what we need to do is to substitute f of x here and substitute f of x plus h there in the numerator, and then we can see what happens afterwards. But what you need to notice is that you already know the value of f of x. You are already given that f of x is equals to x squared. So what you need to do is to find the value of f of x plus h. So from this equation, this is f of x. We want to find what? We want to find f of x plus h. So it means we should put x plus h there, and here as well we should put x plus h, because if there's x here and there's x there, so if we want to change it to x plus h, it means we should change the right hand side as well. So to find f of x plus h, we will say f of x plus h is equals to, we open brackets because there's squared there, so we put x plus h all squared, and then we simplify this. Simplifying this will be, we will have x squared plus 2xh plus h squared. So our f of x plus h will be equals to x squared plus 2x h plus h squared. So now what we need to do now, we did get the value of f of x plus h, and we already have the value of x plus h. So it means we want to substitute f of x plus h, and then we subtract f of x, and then we see what happens after. So the equation for first principles states that it's f of x, f prime x is equals to the limit, do not forget the limit, as h approaches 0, right? We know that it's f of x plus h minus f of x all over h. This is the equation. So now we do the substitution. So the first thing we do, we write down the equation. The second thing we do, we substitute. So we have f of x, f prime x is equals to the limit as h approaches 0. You keep on writing this limit, guys. I will tell you when to stop writing the limit. F of x plus h. Remember that we did find f of x plus h equals to what? Equals to x squared plus 2xh plus h squared. So we need to come and substitute here x squared plus 2xh plus h squared, right? And then now there's a minus. Minus what? Minus f of x. What is f of x? F of x is equals to what? F of x is equals to x squared. It was given to us. So we subtract what? We subtract minus x squared, all divided by what? All divided by h, right? So yeah, the first thing you need to do, you need to find the value of f of x plus h, and then after finding f of x plus h, you substitute in the equation, and then after substituting in the equation, there needs to be terms that will cancel out. So in this case, x squared will cancel this minus x squared, and then what will be left? We'll be left with f of x, f prime x equals to the limit as h approaches 0 into 2xh plus h squared over h. So now, you guys, you notice here that we are given h. You guys know that if we do put a, if we let this to be 0 and 0 and 0, this will be no solution. So what we need to do, we need to manipulate this equation in such a way that when we put a 0 in the remaining h, we won't get an undefined, we'll have a defined value, or we'll have a real solution. So now, the first thing I said you should do, you should write down your equation. After writing down the equation, find out what the value of f of x plus h is, and you're already given the value of f of x. And then afterwards, I told you that there should be terms that are cancelling out. After there are terms that cancel out, what you do, in the remaining part, you need to get rid of h. You need to get rid of h, but in trying to getting rid of h, what you need to do, you need to think of the things you learned in algebra, your common factor rules and other rules, but in this case the common factor rule will be applicable. So if you notice in our numerator, we've got h here, we've got another h there, so which therefore means that we can factor it out, limit as h approaches 0. So now we've got h here, so we'll have 2x plus h. So factoring it out means that if this equation and that equation, this term and this term, they're exactly the same, because you have 2xh plus h squared. If I multiply this here, I will have this h plus h times h, I'll have h squared. So it means this term is a term in that, like, it's the same thing. There's no difference between the two. So you've got h here as well that was remaining. So this h will cancel this h, and then what will be left will be the limit as h approaches 0 of 2x plus h. So now what you need to do, you need to let this h be 0, and then you will have a solution in this case, because initially you didn't have a solution here when you were substituting zeros in the place of h. But now in our remainder, if we put 0 in the place of h, we won't have an undefined solution. So now we will put 2x plus, we let this be 0. So now the minute you let this be 0, now you don't need to write the limit anymore. So now the final solution will be f prime of x is equals to 2x. So this is your what? This is your defined solution. So as mathematicians did figure out a way of deriving without using first principles, but getting into the same answer. I will show you just now how you derive using that rule. So after establishing the way of deriving from first principles, there was a rule, or mathematicians noticed that whenever they derive using the first principles, there is a pattern that their answers, or it's a pattern or a series of answers that they usually get. For instance, now we had an equation f of x. We were given an equation f of x is equals to x squared, but our answer, the answer for this, using first principles, the answer was 2x, or was found to be what? To be 2x. So now there is a shorter way of getting into the answer, but that way doesn't use the first principles. So it has a general equation. Its general equation is given by f prime of x is equals to n x n minus 1. So now if you derive f of x using this equation, you will get to this answer. You will get to this answer. So which means that not all the time you have to derive some equation using first principles unless you are told. So if you're not told, they only tell you to derive. So this is the general formula that you can use. You don't have to go as far as deriving using first principles, though you will get to the same answer. So let me help you derive this using this general rule. So we are given f of x is equals to x squared. So now what you need to do is so f prime of x will be equals to, you take your exponent, you multiply it into your coefficient. So 2 times 1, it will be 2, and then you will take your x down, and then 2 minus 1, it will be 1. So this is 2x. So the answer is actually what? The answer is the same. So if you're not told to derive using first principles, it's okay to derive using the rule or the general formula of deriving, which is n into x into n minus 1. I can derive other equations if you would like, but yeah, if this section is not clear, you can just let me know. I'm gonna make a lot of videos with regards to derivatives and their functions and how to sketch it, and also maybe do application of calculus as well. Yeah, thank you so much. I hope that you guys do understand the video, but if there's some part that is not clear, you can always ask, and I will attend to your question and give you a solution if possible. But yeah, I believe there will be a solution to your question. Thank you.